day, Acute Angels. Welcome to our new learning episode. I am Teacher Nancy B. Pineda, your teacher for Grade 8 Mathematics.
Good day, Acute Angels. Welcome to a new learning episode. We are now in the fourth week of the quarter 4 of Mathematics 8. In this learning episode, we are expected to prove properties of parallel lines cut by a transversal. Before we start, let us recall that parallel lines are coplanar lines that do not intersect. For our illustration, use two arrows to indicate lines are parallel. We can use these two slanted lines to denote that two lines are parallel. This means it is parallel to. We can say that for our first illustration, we have line L is parallel to line M. And for our second illustration, we can write it in symbol as line AB is parallel to line CD. Next, let us talk about transversal. We already know the definition of parallel lines. Again, the definition of parallel lines are coplanar lines that do not intersect. Let us define now the transversal. As you learned in grade 7, a transversal is a line that intersects two coplanar lines at two distinct points. The following illustration shows that line T intersects line M and line N in two distinct points. This is what we call the transversal. In symbols, we can write it as line M is parallel to line N cut by transversal T. The following angles were formed when the transversal T intersected line M and line N. We have angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, and angle 8. The following angle pairs are formed when two parallel lines are cut by a transversal. But before we proceed to the angle pairs, let us first identify the interior angles and the exterior angles formed when two parallel lines are cut by a transversal. When we say interior angles, these are the angles inside the two parallel lines. For the same illustration, the interior angles of line M is parallel to line N cut by transversal T are angle 3, angle 4, angle 5, and angle 6. Again, these are the interior angles. Next one, we have the exterior angles. The exterior angles of the parallel lines M and N cut by transversal T are angle 1, angle 2, angle 7, and angle 8. We may now proceed to the angle pairs formed when two parallel lines are cut by a transversal. There are 5 classifications of angle pairs formed when two parallel lines are cut by a transversal. We have the alternate interior angles, the alternate exterior angles, same side interior angles, same side exterior angles, and the corresponding angles. We will discuss them one by one. I know that this was also discussed to you when you were in grade 7. Can you still recall the conjectures made relating these angle pairs? The relationships between angle pairs formed by parallel lines cut by a transversal are stated in the following postulates and theorems. Let us start with the alternate interior angles. The alternate interior angles are two non-adjacent interior angles on opposite side of the transversal. Using the same illustration, if M is parallel to N and cut by transversal T, we have the pairs of alternate interior angles, 3 and 6, and angle 4 and angle 5. The theorem for the alternate interior angles is, if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. If M is parallel to N, then angle 3 is congruent to angle 6, and angle 4 is congruent to angle 5. You can prove this theorem for a particular angle pair, and the other angle pairs can be proven similarly. We'll have our examples for this later on. Next, we have the alternate exterior angles. Let us first define this. Alternate exterior angles are two non-adjacent exterior angles on opposite side of the transversal. So the pairs of alternate exterior angles are angle 1 and angle 8 and angle 2 and angle 7. The alternate exterior angles theorem states that if two parallel lines are cut by a transversal, then the alternate exterior angles are congruent. So if line M is parallel to line N, then angle 2 is congruent to angle 7 and angle 1 is congruent to angle 8. Let us proceed to the same side interior angles. The same side interior angles is defined as two angles that are on the same side of the transversal and on the interior of or between the two lines. The pairs of same side interior angles of line M parallel to line N cut by transversal T are first, angle 3 and angle 5, and angle 4 and angle 6. The same side interior angles theorem states that if two parallel lines are cut by a transversal, then the interior angles on the same side of the transversal are supplementary. Again, when we say supplementary, the sum of the two angles is equal to 180 degrees. So when we add the pair of same side interior angles, the sum would be 180 degrees. Example, the measure of angle 3 plus the measure of angle 5 is equal to 180 degrees. And for the second pair, angle 4 and 6, the measure of angle 4 plus the measure of angle 6 is equal to 180 degrees. For our next angle pair, we have the same side exterior angles. The same side exterior angles is defined as angles outside the parallel lines and are on the same side of the transversal. Referring to the same figure, if M is parallel to N, then the two pairs of same side exterior angles on the same figure are angle 1 and angle 7 and angle 2 and angle 8. The same side exterior angles theorem states that if two parallel lines are cut by a transversal, then the exterior angles on the same side of the transversal are supplementary. Same with the same side interior angles, the same side exterior angles are also supplementary. So when we add the measure of angle 1 plus the measure of angle 7, the result will be 180 degrees. The same is true with angle 2 and angle 8. The measure of angle 2 plus the measure of angle 8 is equal to 180 degrees. And lastly, we have the corresponding angles. The corresponding angles are two non-adjacent angles, one interior and one exterior on the same side of the transversal. If M is parallel to N, there will be four pairs of corresponding angles. These are angle 1 and angle 5, angle 2 and angle 6, angle 3 and angle 7, and angle 4 and angle 8. As you can see on our first pair, angle 1 and angle 5, angle 1 is an exterior angle and angle 5 is an interior angle, and they both lie on the same side of the transversal. Same is true with angle 3 and angle 7. Angle 3 is an interior angle and angle 7 is an exterior angle. These pairs of angles are non-adjacent angles. Same is true with angle 2 and angle 6. Angle 2 is an exterior angle and the non-adjacent angle, angle 6, is an interior angle. And lastly, we have angle 4, which is the interior angle, and its non-adjacent angle pair, which is angle 8, is an exterior angle that lie on the same side of the transversal. And for the corresponding angles postulate, if two parallel lines are cut by a transversal, then each pair of corresponding angles are congruent. Therefore, angle 1 and angle 5 are congruent, angle 2 is congruent to angle 6, angle 3 is congruent to angle 7, and angle 4 is congruent to angle 8. Again, the relationship between pairs of angles formed by parallel lines cut by a transversal. If two parallel lines are cut by a transversal, then the alternate interior angles are congruent. The alternate exterior angles are congruent. The interior angles on the same side of the transversal are supplementary. The exterior angles on the same side of the transversal are again supplementary, and the corresponding angles are congruent. Let us try these examples to better understand the concepts on parallel lines cut by a transversal and its theorems and postulates. Refer to the given illustration in answering the following. We will answer items A to F as we go through our discussion. Let's start with letter A. Again, refer to the given illustration in answering the following. We will use the same illustration for items A to F. Let us begin. For letter A, if the measure of angle 3 is equal to 60 degrees, what is the measure of angle 6? For our solution, let us first analyze the given illustration and the given data. For letter A, we have angle 3 and angle 6. Can you identify the name of the angle pair formed by angle 3 and angle 6? I will give you 3 seconds to identify the name of the angle pair formed by angle 3 and angle 6. That is right. Angle 3 and angle 6 are alternate interior angles. And as discussed earlier, the alternate interior angles are congruent. Therefore, the measure of angle 3 is congruent to angle 6. And since it is given that the measure of angle 3 is equal to 60 degrees, therefore, the measure of angle 6 is also equal to 60 degrees. Easy, right? Let us now proceed to item B. If the measure of angle 3 is equal to 55, what is the measure of angle 5? Again, can you name the angle pair formed by angle 3 and angle 5? That's great! Angle 3 and angle 5 are same side interior angles. And I know that you know that same side interior angles are supplementary. Again, supplementary angles are angles whose sum is equal to 180 degrees. Therefore, when we add the measure of angle 3 plus the measure of angle 5, the result should be 180 degrees. The given is the measure of angle 3, and we are tasked to find the measure of angle 5. So, substitute the measure of angle 3 to our equation. We have 55 plus the measure of angle 5 equals 180 degrees. Next, we subtract negative 55 on both sides of the equation. We have 55 minus 55 plus the measure of angle 5 is equal to 180 degrees minus 55. The result is the measure of angle 5 is equal to 125. To check our answer, let us try to add the measure of angle 3 plus the measure of angle 5. 55 plus 125 is equal to 180 degrees. Therefore, angle 3 and angle 5 are supplementary. Next, we have item C. For item C, if the measure of angle 1 is equal to 120 degrees, what is the measure of angle 6? Since angle 1 and angle 6 do not fall under the angle pairs formed when two parallel lines are cut by a transversal, let us try another strategy to find the measure of angle 6. First, let us try to use angle 1 and angle 2. Angle 1 and angle 2 are linear pair, and linear pairs are supplementary. Therefore, the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. The measure of angle 1 is 120. We can use angle 2 to find the measure of angle 6. But first, let us identify the measure of angle 2. To get the measure of angle 2, we have to subtract 180 minus 120. So the measure of angle 2 is equal to 60 degrees. Now that we know the measure of angle 2, we used angle 2 since angle 2 and angle 6 are corresponding angles and corresponding angles are congruent. We can say that since the measure of angle 2 is equal to 60 degrees, therefore the measure of angle 6 is also equal to 60 degrees. Next, for item D, if the measure of angle 8 is equal to 110 degrees, what is the measure of angle 4? Angle 4 and angle 8 are corresponding angles, and again, corresponding angles are congruent. Therefore, angle 8 is congruent to angle 4. And since the measure of angle 8 is given, which is 110 degrees, therefore, the measure of angle 4 is also equal to 110 degrees. Way to go, grade 8 learners! We are now on item E. If the measure of angle 2 is equal to 50 degrees, what is the measure of angle 7? Can you identify the angle pair formed by angle 2 and angle 7? What is it then? That is right. Angle 2 and angle 7 are alternate exterior angles. And what is the relationship between the alternate exterior angles? That is right. Alternate exterior angles are congruent. Therefore, angle 2 is congruent to angle 7. And since the measure of angle 2 is given, which is 50, the measure of angle 7 is also 50. And for our last item, item F, let's try a quite challenging one. Find the measure of angle 5 when the measure of angle 3 is equal to x and the measure of angle 4 is equal to x plus 120. For our solution, let us first solve for the value of x. For you to better visualize and understand the given problem, let us write the given onto the illustration. Angle 3 is equal to x, angle 4 is equal to x plus 120, and angle 5 is unknown. First, let us use angle 3 and angle 4. Angle 3 and angle 4 are linear pairs, so when we add these two angles, the result is equal to 180 degrees. The equation will be the measure of angle 3 plus the measure of angle 4 is equal to 180. Substituting the values of angle 3, which is x, and the measure of angle 4, which is x plus 120, we have x plus 120 is equal to 180. Next, let us combine the like terms. X plus x is equal to 2x equals 180 minus 120. 180 minus 120 is equal to 60. And to get the value of x, we have to divide 2 on both sides of the equation. 2x divided by 2 is equal to 60 divided by 2, giving us the result x is equal to 30. Now that we know the value of x, which is equal to 30 degrees, we can now solve for the measure of angle 5. To get the measure of angle 5, let us first use the two angles, angle 4 and angle 5. And by looking at angle 4 and angle 5, we can say that angle 4 and angle 5 are alternate interior angles. And alternate interior angles are congruent. Therefore, the measure of angle 4 is equal to the measure of angle 5. Let us try to solve the measure of angle 4 using the value of x. Substitute the value of x 30, we have the measure of angle 4 equals 30 plus 150. So the measure of angle 4 is equal to 150 degrees. Since the measure of angle 4 is equal to to the measure of angle 5 is also equal to 150 degrees. Again, the measure of angle 5 is also equal to 150 degrees. And another way to solve for the measure of angle 5 is that we can use the measure of angle 3 or the value of x and angle 5. We know that angle 3 and angle 5 are same side interior angles, and same side interior angles are supplementary. The measure of angle 3 plus the measure of angle 5, the result is 180 degrees. To get the measure of angle 5 using its corresponding angle, angle 3, which is equal to 30 degrees, we have to subtract 180 minus 30. The result will still be the same. It is equal to 150 degrees. And that's it. We are now down to our last two examples. For our last two examples, we are going to prove statements. And I believe that you are great in proving statements using the two-column proof. Let us begin. Refer to the given illustration. Line B, line S, line T, angle 1, angle 2, and angle 3. Given that angle 2 and angle 3 are supplementary angles, prove that line B is parallel to line S. For our first statement, let us write angle 2 and angle 3 are supplementary angles. The reason for this is it is given. For our next statement, we can see that angle 1 and angle 2 form a linear pair. The reason is by the definition of linear pair. For statement 3, since angle 1 and angle 2 form a linear pair, we can say that angle 1 and angle 2 are supplementary angles by applying the supplement postulate. The supplement postulate states that if two angles form a linear pair, then they are supplementary. Next, for statement 4, we can say that angle 1 is congruent to angle 3 by the supplement theorem. For statement number 5, we can now prove that line B is parallel to line S by applying the same side interior angles theorem. Since angle 2 and angle 3 are supplementary, therefore, line B is parallel to line S. And for our last example, complete each statements and reasons. Refer to the given figure. This will also serve as your activity for week 4.
You may type your answers on the comment section, take a screenshot of your answer, or you may write it on your notebook and send it to your math teacher. That is all for now. I hope you learned and enjoyed our lesson for today. Don't forget to send your answers to your respective math teacher. Again, this is Miss Nancy B. Pineda, your Math 8 teacher. Until next time, have a nice day, be safe, and God bless us all.